Welcome everyone to Digital Earth Academy. We're just about to get started, and today we're talking about weather. So 5 seconds. And hello, welcome officially to the program. This is Digital Earth Academy weather. Thank you so much for joining us. Now, before we begin, I do want to respectfully acknowledge that the Denver Museum of Nature and Science is on lands traditionally stewarded by the Ute, Arapaho, Cheyenne, and Osheti-Shikoan people, and that lands all over the world have been and continue to be stewarded by Indigenous people. During this program, you'll have a couple of ways you can interact with us. You can put questions in the chat. Sometimes our presenter, Bob, will ask you some questions, and we'd love to have you put your answers in the chat. And besides that, we can just have a wonderful show. And I would like to introduce at this point our wonderful geologist and weather expert for the day, Bob Raynolds. Take it away, Bob.
Yeah, thank you, Mitch, and good morning, everybody. And it's wonderful to have you joining us today for Digital Earth Academy. And today our topic is weather. And for those of you who were with us last time we had an event like this, we were talking about climate. And so there's going to be a discussion here about weather and about climate, and be thinking about that and what the differences are. And you'll find that one of the common things that people do all over the world, and I've traveled all over the world, when they meet each other and want to start a conversation, they'll often talk about the weather. And wherever you go in the world, there'll be concerns about, is it too hot? Is it too cold? Is it too dry? Is it too wet? And there'll be discussions like that. So it's a pleasure for me to start our conversation talking about the weather. And as Mitch was asking a few minutes ago, we'd love to see in the chat where you guys are, first of all, because we've got some students from Alaska and some students from Montana, I think. And so tell us where you are, and then what's the weather like where you are? And that's always a way to get a conversation started. It's the way to so-called break the ice. You say, well, what's the weather like? And easy for everybody to talk about. So we're going to build on this question about weather and climate, just again to get started. And I think we've got a poll question that we can come up with right now. And we want to ask you sort of put your thinking caps on. And this is a true or false question. And it says weather is what happens over a long period of time, and climate is what happens every day. And pick a choice of whether you think that's true or not true or false, and then we'll see what your results are. So it's important for people to think about this, because we do live in a time when climate is changing for reasons that we talked about in our earlier program, and we also live in a time where the weather is dramatic, and depending a little bit on where you are, there's more drama or less drama, depending on what the situation is. And we'll have some discussions over the course of this presentation, and I'll mention some dramatic weather features that I've seen in my own backyard here in Longmont. I live just north of Denver in Longmont. And here we have the results, and the phrase as we put it to you was actually false. So it's great to see almost everybody got that answer correct. The weather is what happens day to day, and the climate is the overall pattern. So we have a phrase, we say that climate is what you expect and weather is what you get. So the climate is the long term, which would be years and years and years, and the weather is the day to day to day. So it's what's happening right now. And let's march into this question a little bit, and as we talk about what makes the weather and why is there such a variety of weather features across the surface of the planet. And I'm going to give you the basic underlying science of these questions. And so this is a science presentation. We'll be talking about science in lots of different ways, and you guys can all be scientists, and weather is a way that all of you can become scientists, and we'll stress that through the course of our discussion over the next hour. The energy that drives the weather, the energy, comes from one place. and that place is the sun. So the sun is the driver of the weather. And I've got a demonstration that I can do here with a globe. I've got this beautiful globe made by National Geographic. And I've got a flashlight, which I have to twist a little bit to turn on. Here, I got it turning on. So there's a flashlight. And you can see that the flashlight is I'm using the flashlight to be like the sun. And you can do this experiment at home. You guys can all do this. So you can find a globe and you can shine a light on it and pretend that the flashlight is the sun. And you'll see some very interesting phenomenon just by this simple experiment that you can all do. And the first thing is that the sun is shining directly at the earth, let's say near the equator, which is near the middle of the earth. And that means that it's only grazing the upper latitudes or up near the poles. So the sun is coming straight in near the equator, but up at the poles, up at the top of the sphere that I'm holding in my hand, there's not very much light coming in. And then the earth is tilted on its axis by 23 degrees. So that creates a variable. And then the earth is rotating or spinning, and that creates a variable. And then the other thing that's important to appreciate is that different parts of the earth heat up differently depending on what the surface material is. If you've got a dark sandy beach, for example, if you go to the coast and there's a dark sandy beach, the sand will get really hot from the sunlight shining on it, whereas the water that's nearby will be relatively cool. And that's because of the different heat capacities of the water and the sand, and also because the water is turbulent and the sand is just sitting there baking in the sun. So it's important to appreciate that the earth is receiving energy from the sun, but it's receiving the energy in a very, we call it variable way. I mean, it's different in different places. And why does that matter? Well, it matters because that creates different temperatures at different spots on the Earth's surface. And as soon as you have different temperatures at different places on the Earth's surface, the system wants to become more uniform. And because there's fluids on the Earth's surface, and there's two different kinds of fluids that we're going to talk about. Because they're fluids, the fluids help to redistribute the heat. And the two fluids are, of course, water, and then air. Air behaves as a fluid. So let's, I want to do a quick demonstration here of a physics demonstration talking about pressure and temperature. And we've got a wonderful little physics demonstration that we can do. And Asa is going to man the controls here. And this is a demonstration that you guys can do at home. Again, you can get this app. It'll be in the chat, and it's also in your teacher's materials. And you pump the pump, and it puts air into the box. And you can see the air is represented by those molecules, which are the little blue beads. And as you pump that box, the pressure starts to go up. You can see the pressure gauge right above the pump. The pressure starts to go up. And then, so that these molecules of air, or the little beads, are representing the pressure. And as you put more in there, you're going to get more pressure. But then Asa is going to turn up the heat using that bottom thing. And it's going to represent an area with, let's say it's a hot day, and he turns the heat up. And watch what happens to the pressure. The pressure starts to go up. The pressure starts to go up. And it's going to burst. This thing might even burst. So stand by. Oh my gosh, the lid came right off. You can see the pressure got so high, it burst the lid right off. And so what really happens on the Earth's surface is that as the heat as an area gets heated up, the pressure increases and the air moves, it flows. And so I think we got to put the lid back on, Asa. But you guys can play with this at home. This is a wonderful experiment. It's a great app. And the link is right now, just went into the chat. And I'm not sure if you guys can all see the chat, but in any case, your teachers have the physics demonstration, and you can all do this at home and experiment with it. But from our point of view, we've got to come back to the Earth and look at what's going on with the fluids that we talked about on the Earth. And this first global image shows the flow of air at a very regional scale. So you can see that the air is flowing almost like rivers. And the colors represent the velocity or the speed. So the high speed is in reds and the lower speeds are in blues and greens. And so above us, we live in Colorado. The air is generally moving from the west to the east, meaning from California heading towards New York. And that air is it's a global circulation. And of course, the air is moving in many different directions in many different ways. And I know in the wintertime here in Longmont, a lot of times the wind comes from the north and we get these cold winds blowing from the north and it blows and blows. And I can hardly imagine there's any more air to blow at me. And I call up my sister up in Wyoming. And I say, do you have any air left up there? Because it's all blowing down to me. And she says, yes, it's blowing where I am too. And it's coming from even further north. So the winds are moving all the time. And they're moving from high pressure areas to low pressure areas on the Earth's surface, and they're redistributing the heat. So this is the flow of the air. Now let's look at the flow of the water. This is a similar diagram. We're looking at the whole globe here, and the colors are temperature in this case. And these are fluid flowing patterns in the oceans. And you can see incredibly complicated flow patterns. There'd be little gyres and squiggles and wiggles. And some of you might know the names of some of these currents. There's a current that's flowing on the east side of the United States, and it flows from the Gulf of Mexico up across the North Atlantic. And that's called the Gulf Stream. And the Gulf Stream is a flowing river of water in the oceans. And so the oceans, like the air, like the atmosphere, are redistributing temperature by moving, and the fluids are flowing in the oceans. It's a complicated pattern. It's dictated by the effects of wind, the effects of water density, and also the rotation of the Earth. So you get this very complicated pattern. And we had to stop it right there. Oh, Talia, let's go back and just stop. I just wanted to show that Australia scene just a second, because some of you might know the current that's off the east coast of Australia. We got to go to the very beginning of the video, where Australia's down there in the lower bottom. And I've been told that some students will know about the East Australian current. And does anybody know about the East Australian current? I'm looking in the chat for people to say they might have heard of that. And that's that little yellow swirly thing down there on the lower left-hand side of the globe, where the east side of Australia has a current that moves from north to south, from the Great Barrier Reef down towards Sydney. And I see people thinking of, yes, they're starting to show in the chat that they remember the East Australian current. In any case, these patterns of fluid flow, which include the wind and the waters, are the basic elements that make up the weather that we have on the surface of the Earth. And this is a diagram that shows clouds and rainfall. And again, this is sort of the results of the interplay between the flow of the water and the flow of the air. And here you see the results. You can see storms moving across. Where it's bright colors, it's raining. Where it's blues and reds, it's raining hard. And in other places, it's just standing still. But we're going to investigate some of the effects of weather on the Western United States. And many of you are in the Western United States. We're going to start from the Denver Museum, which I hope many of you have visited. And if you haven't visited us yet, please come and see us at the Denver Museum of Nature and Science. We're right by City Park in Denver. And we're going to take you on a little trip to look at the influence of weather across the western part of the United States. So Asa, let's launch up from here and see where we get to. And we've got some time to wander a little bit. So we'll give you a couple of stories about the weather of Colorado and then the Western United States in general. And I'll remind you that in the regional view, if we think about the western part of the United States and the western part of North America, the winds are generally blowing from the west to the east, meaning from California towards Colorado. So we're up at airplane altitude here. You can see the city of Denver, and we're getting to very high airplane elevations here, and we're almost getting up into space. And now, as we start to see the Rocky Mountains coming in on the left-hand side of the screen, we're actually at satellite elevation. So we've come up all the way up to satellite elevation, and we're looking down on all of the high plains east of Denver and the Rocky Mountains west of Denver. And we're going to go out towards the west and look at what's happening as we look at the influence of weather on the Earth's surface. And you can see one of the things, Asa, we can hold it here for just a second while we're at this elevation. The colors, the brown colors are relatively dry areas, some of the desert areas of the canyon lands. Some of you might have been out to Moab. You might have been to Utah. And those areas are relatively dry. And the mountains of Colorado on the right-hand side of the screen, you can see the greens and the darker colors. Those are vegetated. There's forests and trees. And it's because there's more moisture. And we'll talk about that here in a moment. But the desert areas have less moisture. And of course, the mountain areas have more moisture. And the moisture comes by precipitation. And precipitation is just a fancy word for rain and snow. So the moisture, which is the wetness comes from snow and from rain. And that's how the trees get green. I mean, the trees are made green because there's a lot of rainfall and snow. And the opposite is true in the deserts, where it's still very dry and you have cactuses and bare ground. Now we're going to go out even further west. Let's go a little bit to the west. And you'll see as we move out towards California and the Pacific Ocean. The Pacific Ocean, of course, is a huge expanse of water, and the air that's flowing across the Pacific Ocean picks up moisture, means it gets wet, and that moist air is blown towards the east and blown towards, first to California, and then heads towards Colorado. Now, as that moist air comes off of the Pacific Ocean and blows across California, let's zoom in, Asa, a little bit closer to California, and we'll see the topographic effect and the influence of topography, which is just the mountainous areas. So topography is the elevation differences. And as the moist air is blowing from the left-hand side to the right-hand side, or from the west towards the east, it comes across California, and it crosses San Francisco, which you might see right in the center of the screen is San Francisco Bay. Some of you might have been to San Francisco, the Golden Gate Bridge, and the air flows across San Francisco. And I've been to San Francisco, and it can be very foggy. You get very wet air coming in off the ocean, and it can be cold and clammy in San Francisco. And that air blows across central California. There's something called the Central Valley. It crosses the Central Valley, and it hits a mountain range that's called the Sierra Nevada. And some of you might know what Sierra Nevada means. It's Spanish. So Sierra means, I'm looking in the chat to see people recognizing what Sierra means. Sierra means mountains, yes. And then Nevada means snowy. So the wind is blowing across California. It hits the Sierra Nevada mountains, and the air cools off. And as it cools off, it can't hold as much moisture anymore. And so you get a huge amount of rainfall and snow in the Sierra Nevadas. And that's why they're called the Sierra Nevadas, because they're a mountain covered by snow. And then if you think about it, as you cross over the Sierra Nevadas, and we might back out a teensy bit here, Asa, so you can see the effect of the mountains. And then as you come across Lake Tahoe here, and that's a beautiful lake up in the mountains, but the other side of the mountains, once you cross the mountains, it's super dry. And it's because the air has dropped all of its moisture on the mountains, filling up Lake Tahoe. And then by the time it moves across into Nevada, which is east of those mountains, it's very dry. And you'll see the color of Nevada. It's got a few lakes. There's Mono Lake on the right, Walker Lake, and Pyramid Lake. But Nevada is very dry. It's a desert country. And that's because the air has lost most of its moisture as it crosses the Sierras. Now that air continues to the east as the winds blow from west to east. And as it crosses the deserts, it'll go across Utah. You can see Great Salt Lake there. And there's some wonderful snowfall on the Wasatch Mountains just next to Great Salt Lake and Salt Lake City. And those mountains have some wonderful ski areas. But then the air comes into Colorado, And one of the first mountain ranges it hits as it comes into Colorado is the mountain range near Steamboat. And some of you might have been to Steamboat Springs, which is in northwestern Colorado, and they're very famous for their snowfall. Steamboat has some of the most beautiful snow in Colorado for skiing. And that's because that air that's come across the desert is once again hitting a mountain range. And in Colorado, we get most of our precipitation is up in the mountains. And most of the precipitation comes as snow in the wintertime, and it falls on the mountaintops. And so our Colorado mountains will be snow-capped in the wintertime. And in fact, in many places, there's snow all year round on the tops of some of the mountains in Colorado. And of course, the vegetation or the plants respond to that moisture. And so if you looked at a plant map of Colorado and asked yourself, where are the plants growing? Where are the big trees in Colorado? They're going to be in the places where the water is. And the water is up on the tops of those mountains and on the fringes as the water melts in the springtime and the summer, it feeds the streams that come down off the mountains. And so many of our biggest forests in Colorado are located on the sides of these mountains where you have enough moisture for the trees to grow. And then if you think about it, that water flows not only on the tops of the mountains, but it flows down into the river systems. And in Colorado, you'll see out on the right-hand side of the screen, the green color associated with the river systems that are coming off of the mountains. So the big weather patterns, which dictate where the precipitation lands, really controls the character of the landscape, not only in Colorado, but around the world. And wherever you travel around the world, you'll find that the rainfall patterns are governed by the same kinds of processes that we've been talking about. And whether you're in Africa or in Asia or in South America, you'll find that the vegetation and the character of the land is reflecting the broad scale patterns of weather. And that's a fun thing to know, because as you travel around the world, you'll realize that there's no national boundaries. When you look at the map as a globe, you can't see political borders. The weather doesn't care what country it is, or the weather is flowing right across the entire globe. And every citizen, every person living in our communities on the surface of the earth is feeling the effects of the weather. And that's very true in Colorado. Let's look at the San Luis Valley a little bit here. So we're going to back up. Asa, let's just finish up with a little view of I wanted to show you a famous place in Colorado that's very strongly influenced by wind patterns. And some of you might have been there. So I'm going to ask you to be guessing what I'm going to be talking about. We're going to be flying a little bit south of Denver. We're going to cross South Park, which you see there in the central part of your screen. And we're going to go down towards what's called the San Luis Valley. And it's coming into view on the left-hand side, and you'll see the Sangre de Cristo Mountains are on the right-hand side of the valley. The valley floor has those little circles on it. And Asa, you might just show us what some of those little circles, and I'll ask you to guess what those little circles are. And remember, I said that the vegetation needs water. And what do you think those little circles are there in the San Luis Valley? And I'm looking in the chat to see if people are guessing in the chat. Some of you might know what these circles are. And you already know from what I've told you that the green color is vegetation, and the brownish colors are areas that are pretty dry. And so the bright green areas represent areas that have very strong, yes, I'm seeing it. People are calling it farms and fields. That's exactly what they are. And those fields are irrigated, meaning we've added water to the field to make them green. And the circular ones are circular because there's a center pivot irrigation. It sort of goes around in a circle. It's a sprinkler system that goes around in a circle, and it sprinkles the ground so that you'll see that circular shape. And those are irrigated ground. And then the Rio Grande River is there on the right. So there's some water, there's some vegetation along the Rio Grande River, but a lot of the green fields are because of the hand of man. People have been out there farming and irrigating, and those are fields. They grow potatoes here. It's one of the great potato growing areas in Colorado. But as we look at the San Luis Valley in a regional view, we might back up now, Asa, and just look at it sort of regionally, remembering the winds tend to blow from the left to the right or from the west towards the east. And there's a very famous area. We might have to get north back up at the top. Oh, there, this will work fine. So we're looking, north is to the left, and there's a very famous place right in the middle of the screen. We can drop down towards it. And some of you have probably been there, those of you who live in Colorado, and see if you can guess what I'm talking about. It's become a national park. It's a very beautiful place to visit. It's got some very dramatic features that Asa is going to show us in some detail here. Yes, people are getting, yep. I see in the chat, people are recognizing where we are. And these are sand dunes. And this is the sand dune, the Great Sand Dunes. And some of the largest sand dunes in the world are here. And you might wonder, why are there sand dunes packed into this little area in the San Luis Valley in Colorado? And they're there because of the weather. I'm going to explain it here in a moment. So you can see the beautiful shapes of the dunes. There's all kinds of different patterns. They're complicated patterns, and people can take their snowboards out there and snowboard on those dunes. It's my kids have done that, so I think it sort of wrecks the snowboard, but it's something that you can do. And you can see you could almost get lost in there. It's a very complicated place, and when you're in the middle of those sand dunes, it's hard to see out. You've got to climb up to the highest dune so that you can get your bearings and see where things are. But the dunes are there because of the blowing wind, which we just talked about. The wind is blowing across the San Luis Valley, across the desert areas, as well as those fields where they're growing the potatoes. And the wind is carrying dirt and sand, and then it blows up and over the Sangre de Cristo mountain range. There's what we call a wind gap, which is where the wind can blow across through a low pass on the mountain range, but it can't carry the sand with it. So the wind blows up across the valley, carrying all kinds of sand, and then it's going up over the mountains, and it drops the sand before it crosses the mountains. And so the sand dunes and the Great Sand Dunes Park are there because that's the place where the wind is blowing from the west to the east across the San Luis Valley, and it drops all the sand right there in those dunes. And it's a wonderful place to visit. Little Mendano Creek is there, very interesting little creek, and you can see the water, and the sand stops right at the water's edge in many places. It's a fantastic place to visit. I'd encourage all of you to try to get there just to see how the regional weather patterns are controlling the features on the surface of the earth right here in Colorado. And of course, you can do this wherever you go in the world, but it's one of the great pleasures of living in Colorado is that we have these dramatic effects of weather right here that we can all see. So thanks, Asa, for giving us such a nice tour of the San Luis Valley. And we're going to now switch our topic a little bit, and I want to talk to you about storms. Everybody's interested in storms. You might mention in the chat if you've been in a big storm, if you remember a big storm. And I think we've got a view of a storm in Texas just to show you what storms look like from above, sort of an introduction to the concept. And let's see if we can load. Yeah, here we've got this is, again, you can see the wind blowing generally from the left to the right or from west to the east. And then these are storm clouds seen from a satellite. So we're looking down on the storm, and those bright things are actually lightning. So you've got lightning storms, and this is in Texas, a very powerful storm system. And it's just to show you what it looks like from above. And you can see generally the flow of air carrying from the left to the right or from the west to the east. And then this incredible lightning activity associated with these thunderstorms. And some of you will have seen lightning and thunder here in Colorado. We have very big thunderstorms in the summertime. And so you might mention again in the chat, I'm looking for people to say that they've seen a storm or been in a storm. And while you are thinking about that, you can mention it to each other in your classroom or where you are. I'm going to tell you a couple of stories about storms that I've seen living here in Longmont, just north of Denver. And one of the storms that was very dramatic for me was in 2013. In September of 2013, there was an amazing rainfall event in Boulder, Colorado, centered right near Boulder. It rained and rained, unbelievable amount of rain, like a foot and more of rainfall. And Bruce Raup lent us this video of what Boulder Creek looked like as it was overflooding the bike trails in Boulder. So these are the bike trails going through downtown Boulder, and Boulder Creek was overflowing, and there was huge chaos associated with this rainstorm. And you can just see the rain filled the creek up completely, overflowed, and then it was flowing down the bike trails and flowing down the roads of Boulder. There was this vast amount of water that just had to come down out of the mountains. And I had friends who they had their their basement windows filled up with water, and they had to bail the water out. And one family didn't have enough bailers. They fell asleep at night, and the water filled their basement because there was so much rainfall. And down where I live east of here, and east of Boulder, and the water came down Boulder Creek, and it came roaring down across County Line Road right where I live. And I think I've got a photograph that shows County Line Road. Here was County Line Road, and I went down to inspect it, and you won't believe it. This is the creek is somewhere under the bridge, but it was completely overflowing the road, and there were fish, huge fish, swimming across this highway. And this is where it was going down Boulder Creek, turbulent water. Everything was chaos. It was flooded completely. The animals were suffering and struggling. And I was looking around, and there was a tree, and it had a rabbit in the tree. The rabbit had climbed up into the tree, and it's a little bit blurry because I was trying to sneak up on the rabbit to take his picture. I didn't want to scare him out of the tree, but I've never seen rabbits climb trees before. Have any of you seen rabbits climb trees? So, it was a dramatic flood, and it caused all kinds of chaos in the city of Longmont and the city of Boulder. So that was an amazing event for me back in September, not that many years ago.
And Bob, we've got some people in the chat who have survived storms, including some people who remember that 2013 rain too.
Well, there you go. Yeah, so it was an amazing time. And then just this past summer, only a few months ago, I was out with my goats. I live with goats, and I've got animals, pigs and llamas and things. And I was out with my goats, and I looked off to the horizon just near my house, just northeast of my house up towards Windsor. And there was this amazing thing. There was a tornado-like object. It turns out it's called a land spout. And you can see that there's another picture of it that'll come up. It'll look even more fierce. There, look at that thing. It was a twistery thing. And I had to grab the goats, and then I was texting my family. I said, oh my gosh, there's a tornado. It's sucking things up. And they said, release the pigs, let the pigs out so they don't get sucked up. So I had to let the pigs out. And then I was holding on to the goats because I thought the goats might get sucked up. And this is a kind of it's like a tornado, but it's actually a spout that comes from the ground up. And it's like a whirlwind or a dust devil, some of you might have seen. And it was very dramatic. And that was back on June 7th of this year. So not that long ago. And it was just this amazing storm. And it did some damage to the fields up near Windsor. So it was not that fierce a storm, not as big as some of the tornadoes we've had in the past, but it certainly was very dramatic. I couldn't really believe it. And all the pigs were safe and the goats were safe, but I was hanging on to the goats because the goats are pretty light. I thought the goats might get sucked up. And the pigs, I wanted the pigs to be able to run for their lives. So the pigs were running off for their lives. But at the end, everybody was safe. So we did just fine. Now we're going to look at, I think we've got—
Bob, just real quick, we've got people who have lived through tropical storms, huge tornadoes, hailstorms, and all sorts of things.
Well, and so there you go. And so Mitch, that's just pointing out that we've all experienced weather, and the weather can be fierce, the weather can be dramatic, and it gives us something to think about and to be careful about. You have to be careful when there's storms. If there's hailstorms, you want to be careful. In Colorado, the hail can get very big, and you will need to find shelter so that you can escape from the hail if it's coming down. And of course, the hail can do great damage to your trees and your plants, as well as your car. I've got one of my little car has little dents in it from hail. I can, if the light is just right, I can see the hail little dimples in my car. So let's, I think we've got one more big storm to show you, and then we've got a couple more things to do before we finish up. But let's look at this big storm coming out of the Atlantic Ocean. I think we've got a hurricane for you. So we're looking at the Atlantic Oceans on the right. The hurricanes usually start coming off of Africa. You can see some of those big white things. Those are storms coming off of Africa. And we're going to look for Hurricane Ida. And Hurricane Ida actually started in the Caribbean, and it's just getting started there near the island of Cuba. It's going to come up towards Florida in a minute. It's going to get stronger, and it's going to get localized. And then maybe once it gets big, so there you can see a great big storm. And maybe if we stop it right about now, right near, you can see there's a little black dot. And I hope you guys can see that. I don't know if the pointer works on this thing, but there's a little black dot it's in the Gulf of Mexico. It's near New Orleans, and that's the eye of the hurricane. And we can see it from space when you're looking. These are satellite images. You can see the thing is swirling around, and it's got the central eye, and now it's coming ashore. It's breaking up a little bit, but that hurricane swept up to the northeast. You'll see that the storm is moving to the northeast, and it went right up to New York City, and it rained something like 3 inches in an hour in Central Park in New York City. Some of the highest rainfall events ever recorded in Central Park happened because of that hurricane, the vestiges of the hurricane as it came across New England. So the weather is something that's happening all the time. That's where it came from there, and then it went up towards the east along the eastern part of the United States. So I want to sort of finish up but tell you guys a little bit more about things that you can do if you're interested in weather, and lots of people are. There's a huge resource base on the internet, and you can see all kinds of YouTube talks about weather, about storms. You can, some little few clicks on the internet, you'll find all kinds of interesting resources. And then there's an even more interesting thing for us here in the Western US, community science project that was started by the Colorado State climatologist, Nolan, up in Fort Collins, Nolan Durskin. He started a program for volunteers to record the weather conditions outside their houses. And my wife is involved in this. She's a volunteer. And whenever there's rainfall, we've got a rain gauge, and she measures the rain gauge every morning if there's rainfall events, and she reports it in. And then her data point shows up on a map. And there are 8,500 people in Colorado who are monitoring the weather as volunteers. And then worldwide, there's 83,000 people now monitoring the weather. And you can go to this system, it's called CohoRAS, it's in Colorado, and you can see different people's reports about the weather as they see it from their houses. And my wife said, well, one of the things that happens in the wintertime is it snows, and she needed a snowboard to record the snowfall. And I didn't know quite what she meant, so I took my old snowboard out and I put it in the field. And she really was thinking about a piece of plywood or something. But we have one of my old snowboards out in the field, and when it snows, she takes the snow off of the snowboard very carefully, and then she weighs it so she can figure out how much snow fell and how much moisture is in the snow. So this is something that everybody can do this. You can join, it's in the chat, the CohoRAS, it's CoCoRAHS, and you can find their website. And if you're interested, or if your family's interested, you can become a weather. And it's a way that the community can come together and show how the weather's variable across their region, and you can all contribute your information. So weather is something that we all have experiences with. It's a common bond that binds us all together across the face of the earth. And wherever you go, It's an easy way to have a conversation with people, to tell them about the things that you've seen and the weather that you've experienced. And now maybe, Mitch, we can, if we've got a few minutes, maybe 4 or 5 more minutes, if people want to ask questions, we can look through the chat a little bit, but we can maybe have some group discussion here if people are interested.
Yeah, absolutely. So everyone, if you have any questions about weather, something that we talked about, or even something that we didn't talk about, please feel free to put those in the chat. Now, we did have one question earlier about wind. Why do wind speeds vary so much?
Well, I think that's a good question, and it's the answer is of course complicated, but the air is going to be flowing from high pressure to low pressure areas, and of course when the air is flowing, that's what we call wind. And so the bigger the difference between the high pressure and the low pressure, the faster the wind is going to be blowing, or the more strongly the wind will be blowing. And of course, it varies according to how high up above the surface of the earth you are. At ground level, the wind doesn't blow that hard typically. And as you climb in elevation, you get up into what we call the jet stream, which is some of those red currents you're seeing on the wind flow map there. And the speed can be very much greater. And I know, for example, if I fly in an airplane from Denver to New York, which I do sometimes, the trip from Denver to New York is usually shorter than the trip from New York to Denver. In other words, the time that it takes to get from Denver to New York is less than the time that it takes to get from New York back to Denver. And you might wonder, well, why is that? And that's because of the wind. The airplane, if it's flying east, it's riding with that current, and so it goes faster. If it's flying west, it's going against that current, so it goes slower. So the wind speeds are quite variable.
Right. Yeah. And so, of course, you can play with that tool, and changing temperature and pressure causes airflow to go faster or slower. So someone else commented they're in Colorado, and their grandparents in Ohio say that lots of times the weather we get in Colorado, they get in Ohio a couple days later.
Well, so why do you think that is? And if you think about the maps that we've shown you and the way the flow of air moves across the United States, you can see that general tendency, and it depends a little bit on the situation, but the general tendency is for the systems to move from the west towards the east. So if we're living in Colorado, we might get a big storm, and if the winds are carrying it to the east, a day or two later, that same system will have gotten to Ohio. And it'll depend on how fast the winds are blowing and things like that, but you can see that is generally true. And we know that. Another way that you know that is, for example, this summer, for those of you living in Colorado, we had many days where it was very smoky here in Colorado. And the smoke was coming from the west, and the winds were blowing the smoke from the fires in California and in Oregon, and the wind blew all the way across the United States. And some of that smoke went to Washington, D.C. So that's another way that you can see that the winds are generally blowing from west to east.
All right. Yeah. And all right. So if anyone else has any other questions about weather, and again, something we talked about, or if you have a question about weather that we didn't talk about, please put it in the chat, and we'd love to get to it. And also, thank you so much for joining us. This has been super fun so far. What about hail? What are the conditions that cause rain to turn into hail?
Well, that's a good question, and it's one that we're very aware of here in Colorado, because we get hailstorms almost every summer. And what happens is there's circulation in the storms, and the storm systems, we generally tend to think of everything as coming down, but in the storms, there's enough turbulence and circulation that there's actually material carried up. And you can get situations where raindrops are carried up high enough up that it's freezing cold and they freeze. And then it can actually even cycle multiple times, so that the frozen raindrop can go down a little bit and then up again and down a little bit and then up again. And every time it does that, it gets a little bit bigger because there's more ice that accumulates on it. And so some of you might have seen hailstones, and they can be, they can get as big as golf balls, usually not, but those, if you chop them in half, you'll see that there's layer upon layer of ice inside the hail because it's been accreting or accumulating ice again and again as it goes through that cycle of being lifted up and then eventually gets heavy enough that it falls. And I've been in hailstorms where you've got to duck under a tree or something because it comes down, it can hurt your head. You've got to be careful about hail in Colorado for sure.
Interesting. That explains, I've seen models of like the biggest hailstones that ever fell,
Yeah,
and they're very strange shapes.
yeah, they are
And now
very.
that makes it make a lot more sense.
We had some in our freezer a while ago. We put the hailstones in the freezer just so we could show friends. I think we eventually ate them because you can eat hail. It's very nice. But let me finish up with that. I just want to remind everybody where we started. We started with talking about the weather and also climate. And I just want to remind you of the difference because the weather is the very variable or very complicated local patterns that you see on a day-to-day basis. And we can look out the window today. It's a beautiful day in Colorado here. And I can talk to you about the weather today in Colorado. But the climate is a different story. The climate is the long-term, the 10-year, the 100-year time frame. And the Earth's climate is changing. And at the same time, of course, we have changing weather. So we've got two different things happening. And the weather is the local day-to-day events, and the climate is the overall many year-long series of events. So thank everybody for joining us today. And we look forward to seeing you again at our next Digital Earth Academy. Thank you.
Yes, thank you so much. And we just had a slide showing you some of the great resources that we used for some of those cool data visualizations. And you can always search for NOAA and NASA information. Most of it is free and available to the public. So you can always look more into if you want to see more of those wind maps and water temperature maps and things like that. Those should not be too difficult to find. And thank you so much for joining us, everyone. I hope that the weather is just how you like it, wherever you are today. All right.